Thank you for taking the time to be here today, and I apologize for not being in person. So, today we're going to talk about heat stress research and strategies to mitigate it. I know a lot of us, as we start to move into those summer months, that we start thinking about the impact of heat stress, the impact it has on the bottom line, and sometimes it's a little bit complicated and challenging to make sure our effective cooling strategies in place. So our goal here is to really make sure we know what we're doing and have the capability to implement the best and most effective strategies in the barn. So my name is Bart Ramirez. I'm an assistant professor in agricultural and biosystems engineering at Iowa State University. And today we're going to go through a little bit of background on heat stress, mainly what is it and what is the impact. Then we'll talk about cooling technologies and different strategies. And then lastly, kind of recap and kind of go through what you can do in your barn on a day-to-day basis to help mitigate the negative effects of heat stress. So let's begin. Numerous negative impacts on productivity, welfare, health, and most importantly, productivity. So, decreased performance resulting from seasonality represents substantial productivity and economic losses for the U.S. swine industry. And we see this in many different ways. Here's the example from MetaFarm showing the average weight out by month for nursery, finish, and wean to finish barns. And you can clearly see that there's a dip in those finishing weights in our summer months, as it might be in part due to producers tending to uh, market pigs a little bit earlier, but also could be an impact of that reduced daily gain. So if we look at our average daily gain by month, you can see here this is a little bit outdated, but it still paints a good picture of we see a pretty stable value through the first 6 months of the year, and then as we start to hit into that, July, August, September, where we have a much hotter, longer durations of heat stress, we start to see a decrease in performance. If we think about for on the sow farm, we see the heat stress periods in June, July, August, and then what the impact is we have litters affected by the heat stress on sows impacting throughout much of the year, as it's kind of a more of a delayed response. We also see reduced boar fertility kind of in the aftermath of heat stress, and then we then see again subsequent litters affected by that reduced boar fertility. This also can be looked at if we looked at pigs mated per sow per year. And again, you see that number peaking up in the summer months, as that's the residual effect, and decreasing in the colder months is also the residual effect from the previous mating. So when we think about how pigs respond to the thermal environment, we can think of any environmental stressors, whether it's cold stress, heat stress. It has some form of intensity, duration, and the pigs may have the chance to recover from it. So you can think about, a pig being exposed to a really hot day in May versus that same pig later on in August after it's had time to acclimate to those summer conditions. So when the pig is stressed, it can lead to it can change the normal behavior to disrupted, normal immunity to impaired, and normally physiology to also to impaired physiology. And kind of the extent of that stress is really dependent on a lot of different things, such as conditioning, adaptation, nutrition, life stage, genetics, etc. And so really, what happens in heat stress is that level of stress increases, and to a level that's going to result in some impaired or disrupted functions. And our goal really is to mitigate that and keep normal functions in place. So pigs can really adapt through numerous physiological adaptations. As we look at this, we can see the effective environment. You can think of that as the ambient conditions. As that warms up, their pulse is going to slowly decrease. We'll start to see the rectal temperature increase as that heat's not being able to be dissipated from the animal. It causes their body temperature to rise. Then we also see one of the more pronounced effects of heat stress is the increased respiration rate in the pigs. We look at what productivity does, how productivity is impacted as the temperature increases. We see during cold stress, feed intake increases, feed to gain increases. That's because the pigs are going to start eating more to help create more heat inside the body to keep them warm. As they go into their thermal neutral zone, which is in that normal core body temperature range, we start to see, again, the values start to level off. We see a peak in average daily gain. But then as those pigs start to get hot, we see feed intake start to decrease, feed to gain kind of bumps back up, and then average daily gain goes down. So as those pigs gets hot, one of their first mechanisms, and pigs are rather unique since they don't sweat, their first mechanism really is to decrease how much heat's being produced inside the body. And the best way for them to do that is to reduce how much feed they consume. Also plays a very significant role on the thermal neutral zone of the pig. So smaller pigs need a warmer environment. That's why we have set points in the barn that start off warm when the pigs are just placed and slowly decrease as they get bigger. And that has to do with a few things. Small pigs have a high surface area to body weight ratio, not a lot of fat or muscle, and just are generally small in mass, so they tend to lose heat very quickly. Versus as that pig matures and gets bigger, they're able to regulate their body temperature much better, and they need a cooler environment to kind of offset that metabolic heat that's being produced from growth, activity, and other functions. So that's why we see, through nursery growing and finishing pigs, that temperature keeps going down, and then we have tend to keep our sows and boars at even a cooler temperature. Happens. How do pigs respond to heat stress? We basically see focus on the comfortable and hot conditions. So in comfortable conditions, we're going to see pigs are in normal contact, laying somewhat close to each other, but not on top of each other. They have a stable body temperature, normal feed intake, and normal behavior. As soon as that environment starts to warm up, you're going to start to see them spread out. What they're doing is trying to increase their conductivity with the floor, dump more heat into the flooring versus limit how much heat's exposed to that hot air since they can't dissipate as much heat to the air as they can the floor. We also see the body temperature start to increase, panting start to increase, or respiration rate. We see decreased feed intake and water intake. The two tend to go hand in hand. Then also on the behavior side, what we'll start to see is those pens start to kind of be fouled or get wet because the pigs start playing with their drinker. They're trying to use the evaporation of that water to help keep them cool. We also see even higher respiration rates when normal is about 20 to 30. It depends on a couple factors, but when we start seeing that go up into the 50s and higher, we can have a pretty good indication that they're somewhat heat stressed. Environment, I've said this word a few times, but it's basically kind of what the pig really feels or experiences. It's a combination of many different things. Air temperature is not the only parameter we use to describe the environment. It's generally the main and most common one. It's the one we can easiest relate to, but really to get a picture of what all goes into heat stress is we have to think about relative humidity, airspeed, air temperature, surrounding surface temperatures, flooring, group size, metabolic rate of the animal, and that kind of gives us an idea of what is that effective environment and what we're actually able to control to kind of offset some of the different things. If we have a high air temperature, we can then use like airspeed. If we have concrete flooring versus plastic or metal flooring, smaller groups versus bigger groups, all these things go into kind of what that effective environment is and how it impacts the thermal comfort of the pig. Basics of heat transfer between pigs and the surrounding. I'm not going to get into a lot of detail here, but it's important to kind of understand these because when we're thinking about how to keep pigs cool, we need to know how they can get rid of heat. So there's four forms of basic heat transfer: conduction, convection, radiation, and evaporation. Conduction is the transfer of heat between two solid objects. So you think about pig lying on the floor is conducting heat from its body to the slats. Convection is a transfer of heat from a solid to a fluid. So as air moves over that pig, it's going to be pulling heat from the pig. Radiation is between two surfaces. So maybe not much as a factor in a modern swine barn, but if you think about like a curtain that's facing south, might be very hot compared to maybe some of the other surfaces in the barn, and that might add a little bit of heat load to the pig. The other most important one for in terms of heat stress is evaporation, which is when water evaporates, it must pull the heat from the object it's evaporating from, and so we'll get into this one in a little bit more detail. So let's first look at the effective airspeed control using tunnel ventilation and how this works. So this first graph here shows the effective airspeed at 61 degrees going over three different sizes of pig. So as we see that the airspeed increases, it decreases that effective temperature or kind of what the pig really feels um, in terms of its overall environment. So pig skin temperature usually is around somewhere between maybe 92 to 95 degrees Fahrenheit. And so there's a big gradient here, almost 30 degrees Fahrenheit, between that pig skin temperature and the environment. So it really can have a large impact at removing a lot of heat from the pig. Now, some of you might say, 61-degree air moving over a 44-pound pig is pretty bad. Agreed. We normally wouldn't see that, but really this is here just to kind of illustrate the power of using that temperature difference between the pig skin temperature and the air temperature, and how much heat we really can pull from the pig. Now let's say the air temperature is 95 degrees, so very close to skin temperature. We have now a really small gradient, so we really can't move much heat from the pig, and that kind of, you see how all the lines are somewhat similar, and you don't really see a major drop in the effective environment. Also consider, what if the air temperature is 105? Which way is heat going? Is it flowing out of the pig or into the pig? So if the pig's unable to get rid of heat from other forms of heat transfer, such as evaporation, we end up adding heat to the pig, which is going to exacerbate heat stress. So that's why we need some other methods when on those really, really hot days. Other thing you might notice is the difference in the effective environment for a 44 versus 110 versus a 220-pound pig. That really has to do with that surface area to weight ratio. And so if you look at the graph below, you see the high surface area to weight ratio for smaller pigs, meaning they can lose a lot more heat compared to those bigger pigs, which as that ratio decreases, they can't get rid of heat as well to the air. Another thing that we'd like to consider in tunnel ventilation is the temperature rise down the length of the barn. So a lot of finishing barns are right at the 180 to 200 foot long, and most of those barns are designed right around 350 to 400 feet per minute. And so really what that is to limit more than about a 2 Celsius, or about just shy of 4-ish degree Fahrenheit rise down that barn. So we're trying to limit that temperature spread down the length of the barn, and making sure we don't get the pigs at the one end way too hot. So what this also shows is what happens on a really long barn if it's sized for, say, a 200 feet per minute cross-sectional airspeed. You end up with a very, very large temperature rise, because we're not turning the air over fast enough, and we're allowing that heat to accumulate down the length of the barn. So you need something more like 1,000 feet per minute if we're really trying to limit that temperature rise down the barn on, say, a 300-foot long tunnel barn. So these are just things to keep in mind as we think about maybe future designs or evaluating our current ones. I'll talk a little bit about sprinklers. The goal here is to use the water on the animal surface, evaporate it, and then pull that sensible heat right from the animal, and evaporate it into the air. So the evaporation of water requires about 1,000 BTUs per pound of water. There's a lot of different factors that are going to affect this evaporation rate, and how much heat we can pull from the pig. So the airspeed, temperature, relative humidity of the air surrounding the pig, is all going to impact that evaporation rate. But as that water, again, the key here is, as that water evaporates or dries, we're pulling that heat from the pig. And so that's where it gets really critical in selecting the right off times, to make sure we're allowing water to evaporate and we're not constantly wetting the pig, which can create a not so good environment. Here's two charts showing the evaporation potential for a pig that's wetted 10% of its area versus 20% of its area at two different temperatures of 77 degrees Fahrenheit and 95 degrees Fahrenheit. So we see that as the more of the pig is wet, there's a much higher evaporation potential. And as airspeed increases, which is on the y-axis there, we see that evaporation potential also increases. So oftentimes when we're using sprinklers, we need some combination of airspeed and sprinkler to really drive that evaporation rate and really extract the most heat that we can from those pigs. So we often recommend that we start sprinkling around somewhere between about 82 and 85 degrees Fahrenheit. This is really doesn't really matter for body weight, as long as the pigs are somewhat over 100, 150 pounds, depending on the system. But because here we're really, it's the gradient between skin temp and air temp, that's why how these really numbers came to be. Also, you could look at it somewhere between 16 to 20 degrees Fahrenheit over the set point. And again, the goal is to wet the pigs with about 2/3 pen coverage. And then once those pigs are wet, we stop sprinkling and really allow that water to evaporate and extract the heat from the pigs. If you keep the barn constantly wet, which I have done, it was a experiment and we made the environment quite miserable. We had a little malfunction in one of our programs, but that humidity gets really nasty and thick. Evaporation doesn't decrease, and those pigs really aren't able to decrease. And what you see here is kind of a thermal image over the course of about 20 minutes of I wetted a pig and then just kind of took pictures of it, as you can see that water evaporating from the skin. Stir fans. So again, with sprinklers, we're going to have some combination of either stir fans or in tunnel, where there's that elevated airspeed to really help drive that evaporation rate and pull the heat. We typically are going to have stir fans come on around 3 to 5 degrees Fahrenheit below the sprinkler on temperature. So that's somewhere, maybe between 75 and 78 degrees. And our goal is to help start cooling with airspeed. And when that's not enough, the temperature in the barn keeps going up. We then use some form of evaporative cooling to help keep the pigs cool. So when using stir fans, best practices is to make sure we utilize the throw of those fans, have them spaced correctly, have them tilted down towards the pig. Sometimes if we're coming out of winter, we might have the fans more parallel to the flooring and the pigs. And so that's really to help circulate and mix the air in wintertime so we get good distribution. But in summer, we really want to create that draft over those pigs. Next, I'll touch briefly on evaporative cooling pads. So the goal here is to provide a drop in air temperature by evaporating water on that cardboard media in those evaporative pads. So very similar concept to directly wetting the pigs, but here we're now directly evaporating water from the air, which causes the air temperature drop, the humidity to increase, and then we have nice cooled air coming into the barn that's around about 80% relative humidity. This ability to decrease temperature is purely driven by the climate and also the efficiency of the pad. So in a warm, humid climate, shown by that small arrow, we have a very small decrease in incoming air temperature versus if we're in a hot, dry climate, we can have a really large temperature difference coming across the pad. Evaporative cooling pads is that the temperature decreases, we're able to get more cooling as the RH nears 85%. If the outdoor humidity is over about 85%, we really don't have the ability to create much cooling. So we have, somewhere between about 5 and 10 degrees Fahrenheit. When incoming air is dry, we can easily produce, 10 to 15-degree temperature drops. Question I often get is when to turn on pads. So question, do we need to be in maximum ventilation or full tunnel? Is there a minimum outdoor temperature? What should the room temperature be? Do we need to anticipate turning on the pad earlier in the day so we get pre-cooling and maybe avoid a sudden drop earlier or later in the morning? Do we want to start going so we can get the room in uniform conditions? These are all good questions. I often recommend we do want to be in at least the second to last stage of ventilation. We really want to maximize the power of airspeed first and then turn on the pad to then further um, remove heat from the pigs. It's also there's a 80-80 rule. When the outdoor temperature is less than 80 degrees Fahrenheit, the relative humidity is probably greater than 80%. So again, if RH is at 80, we're not going to get much cooling out of that pad. So we might need to kind of wait until that outdoor temperature is a little bit warmer so we can kind of take more advantage of that pad and produce that cooling effect. So this table here just kind of shows some examples of what the outdoor air temperature is, which is dry bulb, wet bulb and dew point, which is going to show how much moisture is in there, then translated to RH, and then what those different exit pad temperatures can be for those different conditions. A pretty typical day on a hot, humid day when it might feel really, really muggy. Our typical conditions here in Iowa would be about 95 degrees Fahrenheit and 40% RH. Be a pretty common. Other things on evaporative cooling pads, these charts just show the efficiency performance and also the pressure drop performance. And so with a common 6-inch pad there in the yellow line, typically size these pads to operate at a face velocity of about 350 feet per minute, which produces about 72% efficiency in cooling. We also size them here to have a relatively low static pressure drop of about zero point 0.5 inches water column. Again, these need to be factored in when selecting sizes and maximum ventilation capacity. Table below just shows it's a rather old, but it shows kind of a comparison of different evaporative pads from different manufacturers. And basically, it kind of shows that there's a range of efficiencies and static pressure losses for these different pads that if we're designing a barn or evaluating, we need to keep this in mind as we go through the process. Common challenges with pads is streaking due to poor water distribution, calcification. If the pads don't have proper bleed off or aren't descaled, this can lead to inefficient cooling. So I've got some weekly and monthly recommendations up there on what to do to keep the pads running at their optimal conditions and extend the life of the pads. Just general things of just cleaning filters, floats, pumps, making sure they work, screens. Um, Also, there too in the middle shows the impact of a new versus an old pad and what the airspeed through it you can and what you can pull. So as the air goes slower through the pad, it's more efficient because it gives the air more time to evaporate that water to produce the cooling. But also is going to create a higher static pressure loss for the fans, which is going to decrease the ventilation rate, which also might lead to maybe some humidity accumulation and temperature accumulation inside the barn. Also, now just going to briefly touch on some general tunnel fan maintenance. As we get into the warmer weather, we really need to make sure that our fans are working properly. Just things like routine cleaning of fan shutters and blades. Simple process, often overlooked, but it has a tremendous impact on really trying to generate the air speeds and the air exchange rates we need to keep our barns, at the proper temperatures above outside. Belt tension, another key one is making sure we're inspecting belts and replacing them. So as that belt starts to wear, it'll cause the RPMs of the fan to decrease, which is going to decrease the airflow performance of that fan. So the chart there shows the effect on a large fan by not having the belts adjusted properly. The lab test results show that this fan should be delivering around 22,000 CFM of airflow, but the fans tested on site had less than 15,000 CFM because of poor belt adjustments. Again, sunken pulleys, again, it's going to reduce the fan speed, which is going to reduce the capacity. That table there shows the effect on airflow, and you can have over a 20% loss in airflow just by having that belt start sinking into the pulley as the pulley wears or the belt wears. And there's some good pictures there that demonstrate what to look for when evaluating pulleys. Another thing we do is make sure everything's aligned, is seated correctly in the pulley. Any misalignment between the motor and the blades is present, it's going to cause those pulleys to wear unevenly, wear prematurely, and again decrease airflow. So what can you do in your facility for tunnel ventilation? We want to make sure we verify airspeed at the tunnel inlet, verify airspeeds in the animal occupied zone. So again, we're looking at maybe the inlet around 600 to 700 feet per minute, and somewhere in the barn around 350 to 400 feet per minute. The best option is to measure about a couple feet off the wall and about 2/3 down lake. The barn will kind of give you a nice average of what that airspeed looks like in the barn. If you measure too close to the tunnel opening, the airspeeds are going to be a little bit higher. You move towards the wall, the airspeeds are going to be a little bit lower. It's also done by just making sure the fans are in proper working condition will also help make sure those airspeeds are where we want them to be. Check belts, dirty fans, variable speed control if they're maybe a newer model fan. Make sure we have enough open area to get the air inside the barn. If you have evaporative cooling pads, things to do is, what's our conditions outside when we're turning the pads on? Are we getting that desired cooling? Make sure we add in pumps, nozzle pressure, spray distribution to that list of keeping in mind what we need to do to keep those things running grid. For sprinklers, we want to make sure, are we getting that 2/3 pen coverage? What's our on temperature? Is it too high, too low? You can also measure the water volume to see how much water is coming through. Just turn it on and watch what the distribution looks like. So again, some key points as we move into spring and summer. It's never too early to get started on that checklist because at some point here we are going to start to need some of this equipment, and it's best to make sure that we know it's all working. I've been in a lot of facilities lately where we've gone through just to check stuff and start to verify function, and more times than not, we just have stuff that doesn't work. Fans don't turn on, so they're skipping a stage, or this fan was supposed to do this and it doesn't. So I'd really encourage everybody that after uncovering tunnel fans and cleaning them, go through and manually flip the switches, make sure they turn on and that they're ready to go when the temperatures get warm. Also making sure curtain machines work. If they haven't ran all winter, they might get seized up. Again, just manually open and close the curtain, make sure that thing actually functions. And so when we need to go into tunnel, our current machine's there and it's reliable. Sprinklers and stir fans, again, just turn it on. Make sure they work. Make sure the solenoid works. Make sure the fans turn on. Make sure they're all working. Just go through and verify everything systematically and manually to verify that they work. Also review controller settings. If you have a standard set point growth curve, it never hurts to go through, make sure, is it programmed correctly? Has it changed? What should it be? Are these temperatures right? Fan differential should be about 1.5 degrees between the later stages. What's your total differential? Is it, are we running like an 8 degree between minimum and maximum? Again, make sure that everything kind of checks out what it should be. On temperature should also be verified. Again, make sure that that stuff hasn't changed over time. and that they're meeting kind of the recommendations and fit within what different systems use. Specifically for pads, just check their condition. Do they need replacement, descaling? Are we turning them off at night to help reduce the algae growth? What's our protocol for maintaining them and make sure our pumps work and we're getting the right water distribution with little streaking. Some of the most important things is watch the pigs. Look at water usage, look at line patterns. For this, you might, as we know, it gets hot during the day, cooler at night. So kind of what you see at different times of the day is impacted by temperature. So we want to make sure we're either repeatedly doing it throughout the day or just making sure we keep in mind what the conditions are and what we expect to see. Also, you just don't know till you measure. It's best if you have the tools like a Kestrel um, and smoke or a tape measure. Just have those nearby if you need to do some math and figure out what's going on. But it's the easiest way to look at the controller, look at water usage, look at your temperature spreads, and figure out what's going on. So with that, I really appreciate everybody's times, and if you have any questions, please feel free to reach out to me below. And again, thank you for this opportunity.